So this formula works for poles of any order. So if phi has a pole of order n at z0, then we can get the residue using this formula. M can be equal to n, or it can be larger than n. Obviously, since you have to differentiate m minus 1 times, you would tend to normally choose m to be equal to n, but there are occasions when it's actually, it really depends what phi is. If phi looks like it would be easier to differentiate if you multiply by a higher power, z minus z naught, then yes, you can choose m to be anything larger than n, larger than or equal to n. So to prove it, we start off again with the Laurent series for phi. Remember, this has a pole of order n, so the Laurent series starts here. Then we multiply by z minus z naught to the m and see what happens when we differentiate m minus 1 times. So let's just concentrate on this term here first of all. So if we multiply this term by z minus z naught to the m, then we end up with b1 times z minus z naught to the m minus 1. Now if we differentiate this once, we'll get an m minus 1. If we differentiate again, we'll get an m minus 2. So we end up with d by dz differentiated m minus 1 times. We'll end up with basically m minus 1 factorial just times b1. So that's basically where the b1, where this factor of n minus 1 factorial comes from. Everything else is going to give you 0. Basically, in this case, if you differentiate a naught times z minus z naught to the power m, okay, if you differentiate that m minus 1 times, you'll still end up with a z minus z naught, which when you substitute in z equals z naught, you'll get 0. So these terms will give you 0 when you finally substitute in z minus z naught. Now, with these terms, the b2 up to bn, when you multiply by z minus z naught to the m, remember m is always greater than or equal to n, you'll always get something which doesn't have a z minus z naught on the bottom. If, for example, m equals n, you'll just get, when you multiply by z minus z naught to the m, you'll just get bn, which if you differentiate gives you 0. If m is larger than n, you'll get bn, for example, if m is equal to n plus 1, when you multiply by z minus z naught to the m, you'll get bn times z minus z naught, which you differentiate will give you a constant. The next time you differentiate, you get 0. So all of these other terms will get differentiated to 0 before you even substitute in z equals z naught.